All right, we are continuing on with section 13.1, relative extrema. I've eaten, so I have more energy, so I won't be screwing up as much. Just wanted to get that out there. We're doing number 31. All right, so we have a function y equals 5 over x minus 1. We need to take the derivative. So we have, remember, this equals 5 times x minus 1 to the negative 1 power. So we have negative 5 times x minus 1 to the negative 1 power. I'm sorry, to the negative 2 power. So we essentially have y prime equals negative 5 over x minus 1 squared. All right, and the thing about this problem is that the critical value, so we don't have a critical value because the only value for x that would lead to a 0 leads to a discontinuity in the graph. Because if x equals 1, then the derivative is not defined at that value. And so the limit of, remember, the derivative is the limit of the difference quotient. And so the limit does not exist. And evaluating this at x equals 1 does not exist either. So f of a does not exist. So it is not continuous. And so because this is a point of discontinuity, we don't have a critical value. But we can look at this value of x equals 1 and just kind of identify the behavior of the graph before and below it, before and after it. So we have 1, we have a negative infinity to 1 interval, and then we have an 1 to infinity interval. So if x is less than 1, so let's say x is 0. If x is 0, then we have 1 in the denominator here, which means that we have a negative value here, so it's decreasing. And if x equals 1, if x equals 2, let's say, then we have 1 squared, again, it's decreasing. So at the very least, we can say that on these intervals, the function is decreasing, because part of the problem is to just identify the different intervals and basically characterize the behavior of the function within those intervals. So that we've done that, but there's no critical value and there isn't a relative extrema for this problem.